In this video, we'll go over all of the problems on the Unit 1 review for the transformations assessment. You can watch every slide if you like, or you can skip to the problems that you have specific questions on. So for the first one, all we're doing is we're looking at the rules, deciding if we have isometries or not, and then also the orientation. So for a translation, our rule is xy maps x plus h. H makes it go left or right. Right if it's positive, left if it's negative. And then y plus k. K makes it go up or down because it's with the y. Positive k makes it go up. Negative k makes it go down. Remember that when you write the rule, you will put numbers in the place of h and k depending on how much it goes up, down, left, or right. With translations, your image and pre-image are congruent. Instead of writing congruent, similar, or neither, I'm actually going to write the other vocabulary word, so it would be an isometry or rigid. And translations have direct orientation. When you slide them, the way that you name the image and pre-image does not change. A reflection over the x-axis. When you reflect over the x-axis, the x-coordinate remains the same, but the y-coordinate becomes the opposite. Reflections are also isometries or rigid because the size and shape stay the same. Reflections do not have direct orientation. They are the only transformation with opposite orientation. When you reflect over the y-axis, the x becomes the opposite, but the y stays the same. Also isometries, and still has opposite orientation. Reflecting over the line y equals x will switch the x and the y coordinate. So xy maps y comma x. Still an isometry, still opposite orientation. All reflections are opposite orientation. When you reflect over a horizontal or vertical line, there is no coordinate notation. So it's kind of a trick question. There's not a rule for coordinate notation. You just have that shorthand. So for a horizontal line, we would use R for reflection. And then you would just write whatever the horizontal line is. Horizontal lines are in the form y equals a number. They're still isometries and they're still opposite orientation. The only difference between horizontal and vertical lines is that for a vertical line, your subscript is going to be x equals a number. Still an isometry, still opposite orientation. All right, for rotations, 90 degrees is the equivalent to negative 270. Remember that positive angles rotate in a counterclockwise direction and negative angles rotate in a clockwise direction. When you rotate 180 degrees, your coordinates will swap places and your new x-coordinate will be the opposite. So it's opposite y, x. When you rotate, doesn't matter how many degrees you rotate, your image and pre-image are still the same. And there is direct orientation. Again, reflections are the only one with opposite. When you rotate 180 degrees, that is equivalent to rotating negative 180 degrees. When you rotate 180 degrees, your x and y coordinates are going to become the opposite. They are not going to switch, they just become the opposite. For a rotation of 270, that is equivalent to negative 90. Your x and y switch, and your new y becomes the opposite. So it's y opposite x. Finally, for a dilation, you're going to multiply both the x and the y by the scale factor. We use the letter k. It doesn't really matter what letter you use, but you will put a number in the place of k. So translations, you add or subtract because that shifts, and dilations, you multiply, because when you multiply, that's either going to make the number bigger or smaller depending on the value of k. If k is larger than 1, it will expand. If k is between 0 and 1, it will contract. Dilations are not isometries. They are non-rigid because the size is going to change. They are still direct orientation, however. Make sure you know these rules for the test. Make sure you know which ones are isometries. They're all isometries besides dilation. That's the only non-rigid one. And then make sure you know if it has direct or opposite orientation. They are all direct orientation with the exception of reflections. Make sure you know that for your test. I promise you all of this will be on your test. All right, so the next several problems, I've given you a rule and you're going to identify what the rule does and then you're going to perform it on the shape. Now, I didn't label these with specific points. You might find that it makes it easier, so I probably will add labels to them. So it doesn't matter which point you call what. I'm just going to call the top point A, and this one B, and then C. So looking at this rule, it has subtraction. So the one that we literally just said it, the only one that has addition or subtraction is a translation. So this is a translation. All right, well, how does it translate? Well, look at the x. You have a negative 8 on the x. X moves left and right, so the fact that that's a negative 8 means that you're going to go left 8. And then on the y, you have a negative 3. Well, y goes up and down, so if you subtract 3 from y, that's going to make it go down 3. So you have two options. The easiest thing, I think, on a graph, like on a graph of the translation, is just literally count 8 left and down 3. So start at A and count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, and put a point there. Again, you guys know I'm using my finger so it doesn't show up as well, and it always wants to put something else there, and then it erases the point for some reason. Oh my gosh, it's so annoying. I'm going to do an X. How about that? It should take point A, which was at 2, 8, and if you go left 8, 2 minus 8 is negative 6. You go down 3, 8 minus 3 is 5. So the point that I graphed should be at negative 6. Oh, no, not negative 6, 5. It should be negative 6, 6 because the point is not 2, 8, it's 2, 9. So let me fix that. And it is at 6, 6 if you look at my coordinates, or as good as I can get it anyways. All right, if we look at point B, B is 6, negative 7. So I can either use the rule and do 6 minus 8, which is negative 2, and then 7 minus 3, which is 4. Sorry. It should be negative 7. Negative 7 minus 3 is negative 10. Or you can physically count from B, 1, 2, 3, 4, 5, 6, where am I going, 7, 8, and then down 1, 2, 3, and you can see that puts you right at -10. And then the same thing for C. C is at -1, -1, so you can count over 8 down 3, 1, 2, 3, 5, 6, 7, 8, 1, 2, 3, so right here. Or use the rule and do -1 minus 8, which is -9, and -1 minus 3, which is -4, and that's where I have the point. So then connect A, B, and C prime together, and obviously that is a terrible looking triangle, but you guys should be using your rulers, and it should look much better than what I just drew. All right, for number 2, again, they gave us a rule. So we can use the rule with the points. I'm just going to go ahead and label them A, B, and C. A, the coordinates are, let's see if we can figure this out. Oops. A is -10, 10. My goodness, I'm having a hard time here. B is -8, 3. And C is 4, 5. So we're going to use the rule. We're going to also identify what that rule is. So the rule tells us to keep X the same and in the same position. All right, so all of my X's that I have are going to stay exactly the same. So they're going to be -10, -8, and 4. And then it says my Y coordinates need to become the opposite. So 10 is going to become -10, 3 is going to become -3, and 5 is going to become -5. So you can graph those new points, but I hope that when you see that rule, you identify it as the rule for reflecting. Remember, when you say it's a reflection, you need to tell me what axis that you're reflecting it over, or what line you're reflecting it over. It doesn't necessarily have to be the axis. When X stays the same, but your Y changes, that is a reflection over your X-axis. If you don't remember the rule, I think once you graph these points, you're going to be able to tell that that does reflect over the X-axis. So A is at -10, -10, 8, B is at -8, -3, here's B prime, and C prime is at 4, -5, which is about right there. So your triangle, boom, 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 not great, but I think you guys can you can tell what it's supposed to do. That is reflecting over that X-axis. Remember that the X-axis is this horizontal axis right here. Okay, that's your X-axis. The vertical axis is the Y-axis, so make sure you don't confuse your X and Y-axis. I know some of you did that on the quiz. All right, for number 3, we're going to reflect across the line, X equals -2. Remember, there is no coordinate notation. We do have our shorthand notation where we can do R and then the subscript of X equals -2. We're going to draw that line, so we're going to go to where X is -2, and then we're going to draw a vertical line, not a horizontal line. From here, your only option is to count each point to the line and then go the same distance in the other direction. So to make it easier, I'm going to label each point. So this top point right here, we're going to call it A. It is 4 units away from that line, so I'm going to count 1, 2, 3, 4, and I'm just going to do a little X because every time I try to do an actual point, it wants to mess me up. Okay? I'm going to do this one right here. B is 2 units away, so I'm going to count 2 units in the opposite direction. We'll call this guy C. C is 1, 2, 3, 4, 5, 6, 7, 8 units away, so I'm going to count 8 units in the opposite direction. Just going to put me right at the end over here. We'll call this guy D. D is 1, 2, 3, 4, 5. Count 5 in the opposite direction. 1, 2, 3, 4, 5. We'll call this guy E. E is 1 away, so that one's pretty easy to count. And then we've got F over here. F is 2 away, so it's going to put us right here, F prime. So I'm just going to connect A to B, then B to C, C to D, D to E, and then E to F, and then F back to A. And there is your lovely shape. Okay, let's look at our next problem. So the next one, we are given the rule. It says XY maps YX. So what are we going to do? We're going to switch our X and Y coordinate. When we switch our X and Y coordinate, that is our rule for reflection over the line Y equals X. So let's label our points A, B, C, and D, and then let's do it. A, the coordinates are -9, 3. So if I switch X and Y, it's going to become 3, -9, which is right here. All right, B, the coordinates are -5, -2. If I switch X and Y, that becomes -2, -5. All right, the coordinates for C are -9, -7. If I switch them, that becomes -7, -9. So right here. And then finally D is 2, -2. So D prime is going to become -2, +2. So if I connect those points, A to B to C to D, there it is, reflected over that line Y equals X. You don't necessarily have to draw the line Y equals X. If you want to, you can. Remember, it starts at the origin and has a slope of 1, so it goes diagonal through your coordinate plane. All right, for our next rule, it says XY maps -y, -x, -y, or opposite x, opposite y. This is the rule for a rotation of 180 degrees. All right, so we're going to label our points, A, B, C. A, the coordinates are 9, -9. So if I make them the opposite, it becomes -9, +9. Right here. B, the coordinates are -3, -6. So if I make them the opposite, it becomes 3, 6. And finally, C is 1, -3. The opposite would be -1, +3. And there is your image. For number 6, we are following the rule xy maps y negative x. So we are switching our x and y, and our original x is going to become the opposite. So this is a rotation rule, and it is a rotation of 270. So because we're rotating 270 degrees, remember that we're going to rotate in a counterclockwise direction. All of our coordinates should move 3 quadrants. So the coordinates for A are currently -7, 8. So I'm going to switch their locations. So the y is going to come in the x spot, and then the x of -7 is going to go to the y spot, but it's going to become the opposite. So 8, 7. So 8, 7 right here. And notice that moved 3 quadrants in a counterclockwise direction. For B, the coordinates are 1, 8. So the y coordinate is going to move to the x spot, and then the x spot is going to move to the y spot, but then become the opposite. So that would be 8, -1. Again, B prime is moving 3 quadrants in a counterclockwise direction. The coordinates for C are -2, 5. So I'm going to put y first and then make my x the opposite. So 5, 2. Again, it's moving 3 quadrants in a counterclockwise direction. And finally, D, which is -7, 5. My y becomes my x becomes opposite and moves to the y position, so it becomes 5, 7. So here is your new shape. All right, now we're getting into some compositions where we're doing 2 transformations at once. So I'm going to go ahead and put an A and a B on this segment, and I'm going to write the coordinates for A and B. A is -8, -2, and B is -4, 9. So the notation that we're given is composition notation. Anytime you see that little dot in between them, that's your composition notation. Remember that the order is reversed. So the first thing we're going to do is the T 9, -8. And the T means translate, so we're going to translate. And we are going to go, since the first number is 9, that means right 9. And since the second number is -8, we're going to go down 8. So you can count right 9 and down 8, or you can do that to the points. Right 9 means you're going to add 9, down 8 means you're going to subtract 8 from the y. So I'm going to just use the rule. So on A, my x coordinate is -8. I'm going to add 9 to it, which is going to become 1. The y coordinate is -2. I'm going to subtract 8 from it, so it's going to become -10. But if I started at A and counted to the right 9 and down 8, that's where I would land. For point B, the x coordinate is -4, and if I add 9 to that, that's going to be 5. And the y coordinate is 9. If I subtract 8 from that, it's going to be at 1. So B would become 5, 1. Now we're going to do the second transformation, which is to rotate 90 degrees. To do that, we need to know the rule. When we rotate 90 degrees, the rule is opposite y, x. So I'm going to take those points that I just came up with in red, and I'm going to do opposite y, x to them. So if I look at 1, -10, the opposite of y is +10, and x was 1. So my final resting place for A is going to be 10, 1. It's technically a double prime. For B, I'm looking at the point 5, 1. The opposite of y is -1, and x is 5. So negative 1, 5 is your b double prime. So we translated and rotated at 90 degrees. Remember that that goes in a counterclockwise direction. The other thing that would be important to be able to do is to write a rule in coordinate notation. So I'm going to start with the translation. All right, we know that we subtracted 9 from the x, and then we added 9 to the x, and then subtracted 8 from the y. But when we rotate it, and this is where it gets tricky, the coordinates actually switch. So that y minus 8 is going to go to the front spot, but it also has to become the opposite. So the y has to become the opposite, and the negative 8 has to become the opposite. And then what was in the x spot moves to the y spot, but it remains the same. I don't need to change anything to the opposite. So negative or opposite y plus 8, comma, x plus 9 would be that coordinate notation rule. Oh goodness, hang on. So that's your final rule right here. So on this transformation, they didn't give us the composition notation, but we are doing two separate transformations. So I'm going to go ahead and label my shape. Just throw A, B, and C on there. And let's go ahead and identify those coordinates. Let me make that look a little bit better. All right, so the coordinates of A are negative 1, negative 9. B is negative 5, 6. And C is negative 2, 7. So it tells us to first do the xy maps, x plus 4, y minus 2. I hope when you see that addition and subtraction, you know that that means we are doing a translation first. So our first thing is going to translate. Remember that the number attached to x tells you whether or not to go left or right. Since it's plus 4, we're going to go right 4. And what that means is we're going to take those 3x coordinates that we just came up with, and we're going to add 4 to all of them. You can also count to the right 4. That's up to you. So negative 1 plus 4 is 3. Negative 5 plus 4 is negative 1. And negative 2 plus 4 is 2. All right, and then it says y minus 2. What's attached to y will make it go up or down. So because it's negative, that means we're going to go down 2. So I'm going to take all those y coordinates and I'm going to subtract 2 from them. So 9 minus 2 is 7. Oops, sorry, that should be a negative 9. So that actually is not going to be a 7. Negative 9 minus 2 is negative 11. 6 minus 2 is 4. And 7 minus 2 is 5. Okay, so we have now translated the points. Again, if you took each point and counted to the right 4 and down 2, you should end up in the exact same location. So for the second transformation, it says we're going to do xy maps yx. That is the rule for reflecting over the line y equals x. So reflect over y equals x. Not the x-axis, not the y-axis, the line y equals x. If you want to draw that line, you can. Remember, that's that diagonal line that goes through the origin and has a slope of 1. It's not very easy for me to draw it since my stylus is not working. But you don't have to draw it in order to do the transformation. So all we're going to do is we're going to take those coordinates and we're going to flip them. So 3, negative 11 becomes negative 11, 3. Negative 1, 4 becomes 4, negative 1, and 2, 5 becomes 5, 2. So let's graph our new points. Negative 11, 3 does go off the graph. Don't stress about it. We will make sure that on the test you can definitely fit it on the graph. B double prime would be 4, negative 1. And then C double prime is 5, 2. So whoop, whoop, real long skinny triangle. If we want to write the rule in one big coordinate notation, we kind of already have the first notation because that was the translation, but then we need to switch the x plus 4 and the y minus 2. So the y minus 2 is going to be written first, and then the x plus 4 is going to be written second. You're not just switching the letter x and y, you're switching what's in the x and the y position. So make sure you get the whole thing. All right, so we've got another composition. This one is in composition notation. So we want to be really careful, make sure we do it in the correct order. Let's start by identifying the coordinates of our point. So we'll call A here. This one can be B, and this one can be C. For A, the coordinates are negative 6, negative 2. B, the coordinates are 4, 8. And C, the coordinates are 8, negative 6. So remember that when it's in coordinate notation, you do it in reverse order. So we're actually going to do the D 0.5 first. Hopefully the D gives it away that it is a dilation, and the 0.5 is your scale factor. A scale factor of 0.5 means that this is going to shrink in half. So it's a dilation that shrinks by 1/2. So I'm going to just take all my points, chop them in half. So negative 6 cut in half is negative 3, negative 2 cut in half is negative 1, 4 cut in half is 2, 8 cut in half is 4, 8 cut in half is 4, and negative 6 cut in half is negative 3. So I could graph those points. I don't need to, but I could if I wanted to. That represents just the dilation. So now we're going to look at the R180. Hopefully you know that that is a rotation of 180 degrees. And R means it's going to be a rotation or reflection. If it's got a degree, that's definitely a rotation. So when you rotate 180 degrees, the rule is to to make your x and y the opposite. So I'm going to take those new coordinates that we just came up with, the ones that we got by doing 0.5x and 0.5y, and then we're just going to make them the opposite. So negative 3 becomes positive 3, negative 1 becomes 1, 2 becomes negative 2, 4 becomes negative 4, 4 becomes negative 4, negative 3 becomes positive 3. And these will make up the points that I'm going to graph. So 3, 1 is right here. That's A double prime. Negative 2, negative 4 is right here. That's B double prime. And C, negative 4, 3. Right here, C double prime. So you can see it gets smaller. And you can see that all of your points have rotated 180 degrees. They have moved 2 quadrants. To get our rule in coordinate notation, we started by multiplying by 1/2, and then we made them the opposite. So your rule is going to be XY maps, opposite 0.5x, opposite 0.5y. Okay, so we just did a lot of graphing on the coordinate plane, following the rules, making sure you knew how to do the rule, how to see what the rule meant. So we're going to kind of do the same thing, but we're just going to do it with 1 point, and we're not actually going to graph it. We're going to strictly use the rule. So consider the pre-image A, which is 4, negative 6, and we're finding the image using the various rules. So for A, it says T, negative 3, 5. T means translation. -3 comes first, so that would be what's on your X. That means it's going to go left 3. And then the 5 is what's second, so that's what happens to your Y, so it's going to go up 5. So from your pre-image point, 4, -6, we're going to subtract 3 from the X, and we're going to add 5 to the Y. So that is going to give us the point 4 minus 3 is 1, -6 plus 5 is -1. So 1, -1. For B, we're going to rotate on the x-axis reflect over the x-axis. When you reflect over the x-axis, the x stays the same, but the y becomes the opposite. So if I take 4, 6, I keep my x the same, so it's going to be 4, but I'm going to make my y the opposite, 4, -6. For C, we're going to reflect over the y-axis. When we reflect over the y-axis, the x changes to the opposite, but the y stays the same. So if I take 4, -6, make my x the opposite, that's going to be -4, and then my y stays the same, that's going to be -6. And looking at B, it looks like I wrote that point down wrong. It's actually 4, -6. So it should have become 4, +6. It would help to write the point down correctly. All right, for D, this is a reflection over the line y equals x. The rule when you reflect over the line y equals x is just to switch the y and the x coordinate. So if I take my point, which is 4, -6, I'm just going to switch them. It's going to become -6, 4. Didn't make anything opposite, just switched. Rotating 90 degrees is opposite y and then x. All right, so 4, -6, the opposite of y would be +6, and the x is 4. Rotating 180 degrees is opposite x, opposite y. You're not switching positions, just making them the opposite. So 4, hang on, that kind of looks like a negative. Let me fix that. 4, -6, the opposite of 4 is -4, and then the opposite of -6 is +6. And if you look at the coordinates, none of these coordinates are going to be the same, even though the rules are really similar. And then finally, well, not finally because there's 2 more, but for 270, the rule is y opposite x. So the y coordinate, let me write this down, 4, -6. The y coordinate is -6, and the opposite of x is -4. And finally, D5 means a dilation of 5. So dilations multiply. So you're going to multiply both your x and your y by 5. So 4 times 5 becomes 20, and -6 times 5 becomes -30. I'm not working backwards, just carrying out the rule. Remember that if you are given the image and you're asked to find the pre-image, you have to work backwards. So on a translation, you would go the opposite direction. So if it said go left 3, you would need to go right 3. If it said go up 5, you need to go down 5. When you work backwards for a reflection, you just have to go right back over the line. So you just use the same rule. For rotations, you need to use the opposite rule. So 90 and 270 are opposites. The opposite of 180 is 180, so you use the same rule. The opposite of 270 is 90. For a dilation, like the one that we just did, if we were working backwards, instead of multiplying by 5, we would divide by 5. All right, number 11 says, describe the transformations that would map rectangle 1 to rectangle 2. So I gave you this one because I wanted you to see that this had a lot of answers, and you don't know which one's correct because it's not labeled, so you don't know the orientation. So for some of you, when you guys look at that, some of you might say, oh, well, it reflected over the y-axis. And yes, it could have reflected over the y-axis. right? It could have also, I guess this really isn't a 1 and 2, you could have also just translated, just slid or shifted to the right. Let me count and see exactly how many it is. I went from this point to this point, that's 1, 2, 3, 4 units. Now, here's how you can really tell the difference. All right, so if this was labeled, if this said A, B, C, D, and then this one said A prime, B prime, C prime, D prime, you can rule out that it is a reflection. And you know it's a translation because it just slid. All of those points are in the exact same position. It has that direct orientation from A to B, it's in a clockwise direction, and A prime to B prime is in a clockwise direction. If the labels were different, all right, so let's say that this one said B prime, this said A prime, this said C prime, and this said D prime, then that would rule out the translation, and you would know it's a reflection. The easiest way to know it's a reflection, look at the orientation. A to B is clockwise, but A prime to B prime is counterclockwise, so that's opposite orientation. So again, on this one, it could technically be either because it's not labeled. But I want you to make sure on your test that you're paying very close attention to that orientation, because that will help you decide. If you see that opposite orientation, you know there's a reflection. Remember that reflections can sometimes look like translations, like in this example, and other times they can look like rotations. And so that orientation will help you eliminate either that it is a reflection, and you'll know it's a rotation or translation, or maybe because it's got that opposite orientation, then you know it has to be a reflection. All right, 12, we are looking for a sequence of transformations that will map A, B, C, D to P, Q, R, S in the examples below. I split it up so they're not next to each other, so I had room to write. So we'll just do them on 2 different slides. One thing that you might find helpful is change the letters of P, Q, R, S to A, B, C, D, or prime. That way you can kind of compare them a little bit better. So A is the same thing as P, so I'm going to change that P to an A prime. Q is B. R is in the place of C, and then S is in D. That way we can kind of look at our orientation. All right, so if I look from A to B on the original, I'm going in a counterclockwise direction. If I look from A prime to B prime, I'm also going in a counterclockwise direction. So that means we do have direct orientation, so we know we do not have a reflection in this picture. And some of you may have thought, well, maybe it reflects over the line y equals x, but it doesn't. So what that means is if it's turned, and so we've got a rotation. So we've got to figure out how to rotate it to get it in the right place. All right, so I need A to be up top, and I need D to also be up top. And then I need my B and my C's to be on the bottom. So remember that we rotate in a counterclockwise direction. So if we rotate it 90 degrees in a counterclockwise direction, make sure you keep that in your head, A and D are going to move to the bottom. And if I rotate it another 90 degrees, so a total of 180 degrees, that's going to put A and D on the right side. And then finally, if I go 90 degrees more, that's going to put A and D at the top. So we're going to need to rotate 270 degrees. So I'm going to start by writing out the coordinates of A, B, and C. Oh, and D. A is -3, 1, B is 1, 1, C is 1, 3, and D is -3, 3. So if I rotate 90 degrees, not 90 degrees, we said 270. Let's see where that puts these points. Okay. The rule for for rotating 270 is y opposite x. So on A, that would be 1, 3. B would become 1, negative 1. C, the y is 3, the opposite of x would be negative 1, and D, the y is 3, and the opposite of x would be positive 3. Okay, so it might be helpful to graph those 4 points just so you can kind of see where they're at. So A is 1, 3, which is right here. B, 1, negative 1, which is right there. C, 3, negative 1, and then D, 3, 3. So it's definitely sitting in the right direction. It's just a little bit too high. So what we're going to need to do now is then shift it so that the points correspond. So if you look at B, it looks like B is right there. We need to go down 1, 2, 3 units. So our second transformation is going to be to translate down 3. And if we do that, it's not going to change the x-coordinate, but my y-coordinates are all going to decrease by 3. So my x-coordinates are going to stay 1, 1, 3, and 3. But my new y-coordinate for A double prime would be 0, which that's where P is at, which we changed to A double prime. Negative 1 minus 3 becomes negative 4. So that's where we want Q or B to be, which is exactly where it's at. Negative 1 minus 3 would be another negative 4. So 3, negative 4 is where R or C prime should be, which it is. And then finally 3 minus 3 is 0. So 3, 0 should be where S is at, which is what it is. So we've identified the transformations, and now we're going to write the single rule. All right, so I've got to combine these two rules into one. All right, so switch the y and the x, make the x the opposite, and then I have to move it down. So I have to subtract 3 from the y position, not from y the letter. So that's where it gets tricky. So y and then negative x is in the y position, and I need to move that down 3. So that's going to be your single rule in coordinate notation. Okay, final one. Here, same kind of idea. If you want to change the PQRS to ABCD, then go for it. If that makes it easier for you, it's completely up to you. Doesn't matter at all. All right, so let's take a look at orientation. If I look from A to B, I'm going in a clockwise direction. If I go from A prime to B prime, I'm going in a counterclockwise direction. So right off the bat, I know I've got opposite orientation, so that means we've got a reflection. So we are definitely going to need to reflect. So then we got to decide what we're going to reflect over. And there is definitely more than one way to do this. I would probably suggest looking to see if the x or the y-axis works. You could potentially use a vertical or horizontal line that's not the x or the y-axis, but I think it will be easier if you use the x or y-axis when you're writing your rule. So we got to look kind of like how it's sitting and think about how am I going to get it to the position that it's in. Would I reflect over the x-axis or would I reflect over the y-axis? And then basically I need to flip it upside down. So that means I'm going to need to reflect over that y-axis. I think I just said y-axis, but I meant to say x-axis. So you can either do that to the coordinates, or if you want to, on this one, it might actually be easier to kind of just draw it. I know it's not perfect, but you can count A to the x-axis, which is 1 unit, and then go 1 unit in the opposite direction. Same thing for D. C kind of goes off the graph, and so will not be. B is right there. And then once you do that, then I think it's easier for you to say, oh, okay, well now I just need to translate it. So now let's figure out how much we're going to translate. Definitely got to go to the right. So I'm just going to count D from D to D. Oh, it didn't change colors on me. D to D. So I'm going to count 1, 2, 3, 4, 5, 6 to the right. And then 1, 2, 2 up. And that would work if you count from A to A prime, B to B prime, C to C prime. It would be 6 to the right and 2 up. So we've identified what happens. So now let's get our rule. So we started by reflecting over the x-axis. When you reflect over the x-axis, the x stays the same, but the y becomes the opposite. Then we went right 6. When we go right 6, that impacts the x position. So on the x position, I'm going to add 6. When we go up 2, that impacts the y position. So on the y position, I'm going to add 2. And that would be your